going to be 0, just like the sodium and the chlorine in this example. If I'm working with an alkali metal, like I formed an alkali metal, or if I'm given an alkali metal that's in a salt or an aqueous solution, it's going to be a +1, because you know all group 1 metals lose that 1 valence electron. Alkaline earths, all group 2 metals lose their 2 valence, their s electrons. Fluorine is always going to be -1. That's a given. I can't promise you the other halogens are going to do that, because you already know there's a chlorate and a chlorite anion where chlorine has a different oxidation state. Bromine does the same thing as bromate, and iodine does several different things. But fluorine is always going to be a -1. Hydrogen is +1. I guess I shouldn't have said fluorine. I should have said fluoride. No, I should have said fluorine is always going to be fluoride, is the way you would say that, I guess. Hydrogen is going to be +1, as long as it's hanging out with nonmetals. And here's where all the exceptions start. Up until I got to step 5, or rule number 5, there were no exceptions. And in chemistry, there are always exceptions. And rule 5 are where those start. Hydrogen, when it's with a nonmetal, is going to have a +1 charge unless it's going to hang out with metals. And then it's what we call a hydride. For example, NaH is called sodium hydride. Now you notice I've got sodium, and I'd already talked about sodium in step number 2. Step number 2 comes before, or rule number 2 comes before rule number 5. So you always follow these rules in the order that they're given. So sodium wins. Sodium gets to be the +1 you expect it to be. That means hydrogen is not going to get to be +1 as well, because it has to total to be neutral as a compound. That means that the hydrogen is going to be -1. So when it's hanging out with a metal, these are super rare. You're not going to encounter them frequently. And oxygen is always going to be -2. Unless, and yeah, there's another rare exception. Those are called peroxides. And that is where the oxygen decides it's going to be a -1 instead. And that's where you get the notorious H2O2, the brown stuff in the bottle. It's 1 oxidation state. It's much more stable as a -2, and it's trying to change back. And you can keep going and get some more.